Uh, Hi everyone, welcome to Google Developer Fest Shanghai. Today we'll be understanding AI agents at a very basic level. I'm Prudhvi and Tarun is my co-speaker who couldn't come today. So those are his details. So we'll discuss about AI agents. I think in the previous talk we understood about Vertex AI reasoning engine and all. Now we'll try to understand what are all the open source level details that are available at the frameworks. So I'm Prudhvi. I'm working as a lead software engineer at EPAM. So I'm currently working on a DevOps agent, and which is used for multiple DevOps operations. And I'm also building a framework which is useful to build all the AOps use cases. So that's where I am. So I'm sure you all might be aware of Andrew Ng. So he tweeted AI agent workflows will drive massive AI progress this year. Right after this tweet, we have been seeing a lot of surge in AI agent frameworks like OpenAI Swarm framework and AutoGen framework and various other frameworks. So what are these frameworks altogether and how are they helping us build these LLM agents? This is something we'll look at right now. So if you actually look at a standalone LLM, there are multiple problems with the standalone LLM. Like for example, if you have only tried building some, just a moment. So let's say take an example of OpenAI's GPT-4 or Claude LLM. You might have tried some use cases which you have by prompting the LLM. So there might be some problems which you might have seen. Let's say, for example, if the use case is only specific to building a feature, there are multiple steps involved in building a software feature. Like, for example, testing, for example, documentation, and there'll be a product managing team who will drive the roadmap around for the feature and all. So if you take a usual software development feature, there are multiple components involved in the feature. So this is something, if you try injecting everything in a single prompt, that becomes difficult for a standalone LLM to work out everything and then give the desired results. That is where these agent architectures are going to help. For example, ChatDev, it has multiple, so given a task, we divide things into multiple components, like how this ChatDev is some agent framework, which actually describes very well related to software development use case. Here, if you see, there are multiple teams related to documentation, other related to testing, coding, and designing. So given a task like build a feature to search, so we will go and divide the task into multiple components and give those tasks to multiple agents which are present here, and then get the things done. So this is specifically the multi-agent architecture. We'll try to understand how these AI agent frameworks are helping us build these multiple architectures and then solve the LLM problems. So at a basic level, if you actually look at the standalone LLM, if I query an LLM like, look at the sky, do you think it will be hot tomorrow? So if so, give me umbrella to hide from the sun. If this is the query, for this query, we need some real-time data. We need to understand how the weather is looking like, and then based on that, we need to answer the user with the question of whether we need an umbrella or not to need umbrella. So if you actually look at the LLM, we need some details like the perception. What exactly is the context? When I ask, look at the sky, the context is probably I'm in Shanghai. I need to know the weather specifically in Shanghai. And also there is some brain component. Like for example, if I'm asking about umbrella and weather, it needs to understand that it needs to find out the real-time details like what is the current temperature, and given the temperature, whether there is a need to prompt the user to get an umbrella or not. So there is some sort of planning and reasoning involved at that component level. And once the planning is done, based on that, let's say, for example, if we need to find out the weather details, we will go ahead and perform some action like probably doing an API call to get the real-time weather details. And based on that, we need to respond with the question whether it is yes or no, right? So at a broader level, we'll be looking at what are multiple components that are involved in building an agent. So these are various components. Like we have described earlier, if you take a standalone LLM, there are certain components like memory problems. You cannot fit everything in the world in the prompt. So that's one challenge we will be dealing with. And the reasoning component, where we need to understand, given the prompt, what are all the steps I need to perform to answer to the user. So that is the planning component. And once I have devised a plan to answer the given query, I need to perform certain actions, maybe in between or maybe at last, I need to perform certain actions and then respond to the user. So as we have looked at earlier, this short-term and long-term memory is where the RAG is going to help the LLMs by injecting some data at the knowledge source level, or maybe the tools where we do some searches or we do some API calls to inject the real-time data and then respond to the users. And planning is the major component of an AI agent. So like how we have seen in the previous example, to answer the given query, what are the various steps I need to perform to answer the query? So the reflection, self-critique, chain of thoughts, and sub-goal decomposition, these are various planning techniques which are helpful in answering various questions. So at a broader level, basically these are going to mimic how we as humans work while answering certain questions or so. Let's say, for example, if we go on researching certain topic, what do? We list out what are all the probably research papers, what is the exact topic we are looking at, and what are various research questions we are trying to answer, and then gather multiple data from these research papers, and then come up with the solution for our research problem. So the same way, this is going to try mocking what we as humans do with various patterns in planning. So these are various patterns, actually. So now we'll try to understand the reasoning and planning component better, because that's the core of an AI agent. So this has been the new research at multiple components level, like for example, natural language interaction, knowledge, memory, reasoning, and planning. These are various research techniques which are available at your disposal. We'll have a look at the reasoning and planning component especially. So at the reasoning component, we have things like chain of thoughts, zero-shot chain of thought, and self-refine. These are various reasoning techniques. And at the planning level, we have point one, planning formulation. How do we devise a plan? And planning reflection focuses on, once we have devised a plan, how are we going to improve the plan or adapt the plan to our use case? Let's say, for example, I've come up with some 10 steps. If it fails at the 7th step, what is the reflective element I need to go and change the plan? So those are the techniques which are going to help perform that adaptive planning, actually, based on the results. So these are various techniques you can have a look at. So if you understand what is the basic idea behind all these reasoning and planning component, the majority of them are focusing on one research at a time. Given the task, what are all the decomposable tasks you could come up with and give to the agent so that it would perform your task very well? Yeah. There is a slight modification at the few-shot prompting level, but we'll try to understand what actually this zero-shot and few-shot prompting is. So zero-shot prompting is basically providing certain instruction to the LLM without any example. So the instruction would be like, what is the entry price of Paradise Cruise, Goa, and what is the timing it opens? So I've just given some instruction to the LLM, but not provided any details as such. So that is where the zero-shot prompting comes. And at the few-shot prompting level, we give some set of examples. Let's say if that example there is not appropriate, it hasn't been changed, but yeah, I can give you one example which could be more appropriate for few-shot prompting. Let's say we have the task of doing sentiment analysis. there are certain sentiments we have defined like positive and negative. So we need to give few examples for the system to understand what exactly falls under positive and what exactly falls under negative. So the representative examples which we provide for the few-shot prompting are the ones which make few-shot prompting. If you provide a single example, it becomes one shot. If you provide 2 examples, it becomes 2 shot. Based on that, that is few-shot. So these are certain prerequisites to understand the reasoning component of chain of thoughts. That is the reason we are going to go through these things. Now, let's try to understand chain of thoughts. Chain of thoughts, so let's look at the example there, right? So Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? So this is a few shot setting where we have given an example that the answer is 11. So the first question answer you see there is basically an example. And below, if you see, if you only use a plain chain of thought, plain few shot, the answer is not correct. It says answer is 8. But if you look at the few shot COT, there we have detailed out with the steps on how the answer is reached. So Roger has started with 5 balls, 2 cans of 3 tennis balls, each is 6 tennis balls, 5 plus 6 is equal to 11, the answer is 11. So this is the detail example which is outlining the chain of thoughts, what are all the list of steps we are performing to come up with the answer. And that's how the few shot COT is able to come up with the correct answer. But in the same case, if you look at the 0 shot COT, here in the below example, a juggler can juggle 16 balls. Half of the balls are golf balls and half of the balls are blue. How many blue golf balls are there? The answer is, it says 8, which is not right answer. If you look at the 0 shot COT, at the answer level, we have kept a statement called let's think step by step. That exactly is the 0 shot trigger for the LLM to understand that we are focusing on thought process and then coming up with the solution. So this is how it improves the overall performance of the LLM. So, and this is one example I've tried on GPT-4 and Gemini. So this, I went to the market and bought 10 apples. I gave 2 apples to the neighbor and 2 to the repairman. I then went and bought 5 more apples and ate. How many apples did I remain with? So all these LLMs, right, GPT-4 or Gemini 1.5 and all, are coming up with pre-built reasoning with this chain of thought examples. So you can go through and find out how these LLMs are behaving at multiple reasoning-based questions. And there's one more chain of thought pattern called tree of thoughts. So it's like, if you look at some of the examples, for example, the earlier example we have seen, the chat dev where multiple agents are detailed. So to perform a single task, we might have to spread out that into multiple tasks and might have to go deeper into those tasks which we have come up with. That's where tree of thought will help us. It is going to extend the chain of thought, but with multiple reasoning possibilities. So kind of like our BFS and DFS. Yeah, so if you actually look at the prompt, let's develop a marketing strategy to increase brand awareness of our new product. So at the chain of thought level, we are going to define the chain of thoughts like this: identify the target audience, research their preferences and behaviors, develop a marketing message tailored to the audience, and choose appropriate marketing channels, especially for the marketing strategy example. And if we come up with the tree of thoughts example, it's going to be like start with the objective of increasing brand awareness, and then branch into different strategies. That is the main key element here, where we are focusing on multiple tasks here, like social media marketing, influencer partnerships, and email campaigning and all. So we might have to think differently for each of the components laid out here. So, and so now we have understood the planning part. So this is where we will understand what actually is the reasoning part and the adaptive part. So this is basically called react prompting. So as we have discussed earlier, if there are some 10 steps we need to perform, if one of the steps fails, what is the fallback mechanism we are going to do? If it fails, how do we come up with a plan that will improve and reach our overall goal? So this is some example. Aside from Apple Remote, what other device can control the program Apple Remote was originally designed to interact with? So in the standard case, which is the standalone LLM, it answers iPod, which is not exactly the correct answer. And if you look at the chain of thought, it is only reasoning. There is no acting here. So it says, let's think step by step, and then it details out, and it says the answer is iPhone, iPad, iPod Touch, which is not the right answer also. And if you also look at only action-based, which is only using tools, not combining both reasoning and action, it will perform action one is searching about Apple Remote, and then searching front row and searching front row software, and then finally it answers yes, which is not appropriate as well. So now we'll come up with the combination of reasoning and acting. So it will first search Apple Remote, and then finds out the next thought that we need to search the front row, and then it is not front row is not found. So it is finding out front row software, and then detailed out, and finally came up with keyboard function keys, which is the final answer. So the main takeaway here is the combination of reasoning and action, which is helping us get the right answer for our task. So this is some example for the usage of tools on how we can utilize LLMs for tool calling and then come up with the right answers. In the interest of time, I'll be moving around. So basically here we are looking at agents with feedback. So if you look at the prompt, it says your available actions are tool string. There we inject what are all the tools available, and then the system will devise a plan which will call those tools and collect the feedback and then come up with the final answers. So if you would like to understand what more about these React agents, you can go through the video by my co-speaker. Now we'll try to understand the code implementation of this agentic flow using OpenAGI. So there are multiple agent frameworks you can try out, like Autogen, LangGraph, OpenAGI, and much more frameworks like Swarm by OpenAI. More or less, all these frameworks are focusing on multiple agentic architecture patterns, like multi-agent or sequential agents or branching out agents and all, which could be useful for your various use cases. So here we declare what are all the components that are needed for agent, basically the tool components and the model which you would like to use and how you want the planning to be done and all. And then we detail out the required tool API keys, and then focus on the planner if you need some human intervention to provide some feedback. So in this frameworks, right, you can utilize either human feedback or tool feedback to improve your overall answering. Those details we can find it out. When you say autonomous, the system will try to understand itself by using multiple tools and all. And then we can declare the model and the tool, which is the surplus search we are using. And this is the query we are giving: how many runs did Rohit Sharma scored in second innings against New Zealand in Bangalore? So the description, do the search and get me only the score, is what will make the system understand what it needs to perform. So, there are multiple cookbooks available, especially related to the OpenAGI framework. You can have a look at these cookbooks and try out your different tasks which you have for agents. So there are some real-time use cases which I have developed for my own use, like coding documentation. I know documentation is a painful task to do even at the start and at the end as a developer. And assignment evaluator is something I've tried as well to evaluate all the applications which we are getting for our company and all. And curriculum content preparation is one, and market researcher is another thing which we have utilized. So basically the main agenda is, given the task, we divide the task into multiple sub-tasks and then decide on some agent architecture, decide all the tools that are needed, what are all the knowledge sources that are needed to perform the task, and then get the task done using LLMs. Thank you, and have my LinkedIn mentioned in this link. You can reach out to me there. If you have any questions, I'd be happy to answer. Thank you so much.
好，谢谢。那么下一位刚才对于那个这位导师的分享有没有问题？可以有。好的，没有问题 ，no problem。No problem. Okay. Next time. 哎，哦，稍微等一下，这位帅哥有一个问题。
Hello, I wonder how you view the future of AI agents, the business opportunities. We know that we have Cursor right now, we have Perplexities, this kind of AI tools. In which area do you think will AI agents be used in the next 3 years? In which areas it will be applied, and how much the market value will be?
Sure, yeah. So I especially found AI agents being utilized at, let's say for example, we have the market research task or coding task, right? I've seen certain type of models doing well at certain tasks. For example, Claude doing very well at coding, and Gemini doing very well at multi-modal tasks.
I'm sorry, can you speak a little bit louder? I can't hear quite clearly. Can you speak? Yeah,
okay, sure. So I see the use of agents by combining multiple models for the given task. Like for example, if you are performing market research and coding related tasks or so, I see that Gemini doing very well at multi-modal tasks and Claude doing very well at coding. So you can combine all these multiple models and then perform the given task in a better fashion. That is where it's going to be very well helpful. And if you look at Cursor, it is only performing the coding, but if you actually utilize multiple agents, it is going to help you also at documentation, also at coding, also at product roadmap. You can try and understand what are all the improvements you can do on top of your existing software if you build a product manager agent. And you can also build a testing agent which will help test your code with multiple edge cases and improve your overall development cycle. So at multiple steps in your software development life cycle, you can deploy different agents which are using multiple models, multiple tools to improve your overall process. Is it clear?
Okay. Can you think of any opportunities outside the realm of software development? Are there other opportunities in other fields?
Sure. So, yeah, market research is one. Probably like anything that is needing real-time data model. So, if you take any LLMs, right, all these are having cut-off data. So let's say if the model is developed on 2024 January, that is the cutoff data for the model, right? So you can give multiple tools which model can use using these tools, and then give you more real-time results. So that is something which you can do. Like if you have any tasks. So I will give an example which I have been doing. So if you take any enterprise, it takes a lot of time for multiple teams. If there are certain tasks which will involve multiple teams, to automate those kind of tasks, agents will be very helpful. Like cross communication,
I'm sorry, could you repeat that? I didn't hear very clearly.
Okay, sorry, you want me to slow it down?
I didn't listen very clearly to your example. Could you repeat that?
Okay, so if there are some tasks which will involve multiple teams, like the technical team, non-technical team, and some other teams, so to collaborate all these teams and get a task done, those kind of use cases you can automate using agents.
Okay.
Probably I can give you some examples. So if you actually look at the documentation use case.
Oh, okay.
So, yeah, I mean, like these are the ways where I have used agents. So think of it like you might have been using LLMs for your use cases, right?
Yeah.
Right. So did you face the problem of injecting entire data into the prompt and LLM not being able to come up with answer? Your prompt might have gone bigger and bigger for your task, correct?
Oh yeah, you mean prompts?
Yes.
Yes, I may have to try a few prompts to get the right answer.
Yeah. So in that particular prompting, especially, you can divide the prompts into multiple sub prompts, which each of them can be given to an agent.
Yeah.
There, let's say you have one bigger prompt and it contains some 10 tasks.
Yeah.
Each task can be given to an agent, which will do the overall, which will perform very well for that particular task.
Oh, I know that.
Let's say you have a financial question. Let's say you are talking something around trading, right? So each of the agent can try a trading strategy and then help you come up with better approach. Let's say a training agent. One agent can help you pick up the news and then give the related news information. One agent can develop, read the company's data and then suggest that, okay, this company is doing good, this company is doing bad. The research on the company data, and the other agent on news, and the other agent can help you come up with trading strategies, which you can utilize by looking at the historical data, and then give you overall suggestion. So if you pick up the task of trading, there are multiple sub-tasks which you have divided into, and each of these sub-tasks are going to help you answer your question of where to invest my money in. So this is where agents could perform well. If you give the same task to an LLM, it becomes difficult for LLM to come up with a suggestion because it cannot perform let's say for example trading. You need to perform some time series analysis, look at the previous data and then come up with a strategy. These sort of things are limited. LLMs cannot do those. For those, we can utilize agents and tools and come up with a better investment strategy for your investments.
Can you come up with one general idea, one idea that it has a huge potential business value, but it might be sold by agents in maybe 2 or 3 years? Just one idea of that.
So anywhere you see challenge with only standalone LLMs, those are going to be automated by agents.
Okay.
Yeah.
Okay. Thanks.
Thank you.